In this final section of this beginner to intermediate Grasshopper tutorial series, we will be placing the shading device just like we had in volume 2, but we'll be using adaptive components. So essentially, we'll be leveraging Revit's adaptive component technology alongside Rhino.Inside to place them. So if you look in the same folder, you should see the adaptive uh, element file, and when you open it, what you would see is this family, adaptive family, that has 4 adaptive points and several points, reference points. One of them which controls how this shading device works. And if you remember in volume 2, let's go back to our drawing here. The shading device pretty much worked the same way as the frit pattern. Okay, so if you had a shading device that went from here to here, that point also moved along the diagonal. Using the same principle, we were able to create the shading device. So for this, we're going to load it into our project as well. Don't want to save anything. And by default, you notice that we can place, 2, 3, 4. And that's, how you place. But we're going to be placing these using Grasshopper. We're not going to be placing them manually. I mean, doing this manually would be ridiculous. So let's delete this and go back to our file. And we're going to go all the way back to, remember where we extracted the cell information of this current panel? Yes, we are going to be using this. See if we can show it. Yes, to get the points of this cell. So what we're going to do is, for this one, we are going to use this dispatch to split this into the cells that belong to our glazing versus our solid panels. So I'm just going to do another dispatch here and connect this data that we had from the subsequent section to here and check what's coming out from here just to make sure. Alright, so it's the ones we need. So what I'm going to do is explode. Let's see, explode. There we go. And now what we have coming out from here are the points that define each cell. But we want 4 points, and because of how things are constructed in the Rhino space, we have 5 because a closed loop. So we have a repeated, like the first value and the last value are repeated. So what we're going to do is do a call. Let's do a call duplicate, and we can just pass in here, and now we have 4 points. Okay, but we want to make sure that our points are going from 1, 2, 3, 4, or in this case 0, 1, 2, 3, because we have our adaptive points that are going, you can see the number 1, 2, 3, 4, so it needs to go in that direction as well. And you also did this in volume 2. So for us to check that, let's do the list item here. You see that it's starting from this point here. So if we do 0 to 3, Let's see what our first point is. Our first point is here. Our second point is here. Our third point is here. And our fourth point is here. So what I'm going to do is shift this list backwards so that our point 1 is here. Do that. Shift list. It's right here. On this list. Shift. Let's see if we can shift by -1. And then now if we connect this here and go all the way back to 0, we see that our point is starting here now. So we have 1, 2, 3, 4. Okay, and just to be certain, let's do this point list and connect this point here. Oh well, let's do this first off. So we have all these excess zeros behind. Let's simplify this. Okay, and now let's do a tree item. So connect this here. Let's rather, instead of doing a simplify here, let's do a simplify here. So we simplify this in this tree. Okay, the path is, let's do 0, 0, 0. Okay, and then that gives us that point. Okay, and then we can put this here. So let's get rid of this. This is just to make sure that we have the right thing. You will notice I'm going to delete this as well. Oh, actually, we can keep this, and then here do a branch, tree branch. These points we want to simplify. Connect this here, connect this here. Okay, so and connect this here. There we go. Hide this, delete this, we don't need it. And then here you can see that let's make this size 1. You can see that it goes from 0, 1, 2, 3. But if we take this and shift this one, connect this, so it's going from 0, 1, 2, 3. This is exactly how we want it. So that's evidence that what we had before is doing the right thing. Okay, so just make sure we have this with our list. Go, we can simplified. We can simplify this some more. And now what we want to do is add an adaptive. Let's do it from here. Build. Add component. So this is in the Revit toolbar. You go to build. You go to add component adaptive. And then the points are the points in this list. On the type, we would set that. So let's copy this type that's here and this family that's here. We copy this. We make sure that we're choosing an adaptive component. Let's see if there's any adaptive or something we can verify. Going back to our project, let's go in 3D. We can go, we want this to be generic. Okay, here's why. Because in this file, this adaptive component, you notice that it's a generic family here. So we want this to be generic model. See if we connect this. Okay, it's not working. So we go to input and element type picker. Then we connect this. Wow, that's because we haven't done any. We want to recompute. Okay, there we go. Now let's click here. Now we have adaptive component. So remember, you always have to hit recompute if you've made changes in Revit that haven't been picked up in Grasshopper. And then what we want to do is fill this. Actually, maybe what we want isn't for this to go in this direction, 0, 1, 2, 3. We want it to be 0, 1, 2, 3. So what if we reverse our points? Because let's place this and see what happens. Okay. Now you see that it's working in the wrong. It needs to be flipped in the other way. So it needs to go from 0, 1, 2, 3, so that they can operate in the same diagonal. Okay. So this is why order matters. So let's do a tree or branch. Sorry, branch. Tree branch. Get these in the path. We can set the path to 0, semicolon 0. That's this. Okay, that's here. I'm going to do a point list and make this 1. Okay, so what if we reverse this? Now we have 0, 1, 2, 3. Again, that's not what we want. So I'm going to test this, do a shift, bring this here, bring this here. We have 0, 1, 2, 3. This is exactly what we want. We just needed to reorder our points. Okay, so it's going from 0 to 1 to 2 to 3. So what we're going to do here is just delete this and reverse this. Fantastic. The unfortunate thing is that this is happening on the back side. Okay, so for us to fix this, flip this, I believe. Let's see what happens. Yes. So, but the problem is we want to do this parametrically, right? So what we can do is set the element, parameter. So set parameter type, so parameter, set parameter. We can go to element, and if you click here, it's called flip. So make sure the spelling is right, and then it's a true false. So toggle. We want this to be true, want this to be flipped, and we connect this. Voila. So see how we've been able to manipulate Grasshopper or Revit elements using the parameters that are in Revit. Okay, so if we set this to 0.75, what does this do? Okay, so this comes up. Okay, so what we would like to do is make sure that we have, maybe we want to do a 0.85. Okay, all the way to, yeah, 0.25. Okay, let's maybe 0.5. So essentially we're just going to do the same thing, and we will let's keep these here. Because the list structure of this adaptive point which is here matches the list structure that is here, which we then use to control the diagonal parameter for the frit. What we want to do is we want to flatten this component here, just like we flatten this element here. Okay, I'm going to flatten, right, and then we're going to drag this all the way, and then copy these two. So copy this, copy this. We're using the same points, panel points, to generate the parameter along the curve. But we are going to reverse this, make this, yeah, let's make this 0.85, 0.25, and then apply this to, so what's the parameter we're applying this to? We're applying this to the aperture. Okay, so here what we want to do is set, this is, we want to set element parameter, connect this here. Now we can always connect this to here actually, so that this happens when this happens, or this happens after this happens, okay, instead of having them run in parallel. Depending on the task, you might want them to run in parallel. So here we have 64 elements. The parameter we want to set is aperture. Okay, we connect this here, and then these values that we remapped, we connect here. Now we wait, see what happens. Voila. You notice that the same thing, it slowly increases here, doing the reverse. So let's look at this in 3D. Okay, this is starting to look like the panels that we had in volume 2. But something that's here is the depth of these panels. So that is how far away this point is from the current panel. We can always set these again. It's called the depth. Okay, and let's make that standard. Okay, so I can right click, select all instances visible in project, and I'm just going to adjust this manually. So let's make this maybe 1. Great. Now we go back to the 3D view, and you can see it's not sticking out so much anymore. Okay, you've been able to create this parametric curtain panel and shading just like you did in volume 2, but now in Revit, using Revit native elements. That's the power of Rhino.Inside. So if you had to adjust this curve, a tractor curve that we had before, you should see change. And now you can, obviously in a real project, you won't have variations in all of these panels. You have maybe 5 or 4 standard panels for ease of construction. So an assignment to you is, how would you standardize using Grasshopper? Standardize the panel types parametrically, such that as you kind of update this curve, it maintains the number of unique panels, maybe 4 unique panels that you have. We did that in volume 1, so try to take that knowledge from volume 1 to creating panel types or panel groupings. Use that in here in volume 5. And if you have questions, leave us a comment or join the Discord channel.